Hello, everyone. Welcome back for another week. We're going to be taking a look at week 3. Let's get started. Week 3 and chapter 3, excuse me. Okay, we're back. And again, we're going to be talking about week 3. These are the different tools for data organization. So we collect data, we organize it, we have tools to analyze it, and then we get into presentation, using things such as Tableau and others to talk about data visualization. And again, we talked about some of the ways that healthcare organizations collect data, and we have data that's often multidimensional. For example, we're looking at data from the perspective of a provider, the patients, the information about patients, the information about insurance companies, and within insurance companies' coverage, services, all these different things. And so as a result, we keep this in databases. And we've always had these. We used to keep certain things like a master patient index on little cards, and then we put them on microfilm and microfiche and what have you. And basically, it's an organizational structure so we can generate data analysis and reporting. So at a simple level, we have a master patient index. So it gives us a certain amount of baseline data on a patient. Then we look up the patient's medical record number. Databases do this now electronically. So we're basically getting this collection of data, as it says here, integrated records. And we have this type of different structure, and we see this in databases. And with a relational database, if you will, all these elements are related. So to get into what a database is, we'll be doing this with the Access projects we have for you. We'll be looking at a couple of different arrays of data. First of all, we have data variables or attributes, and those are things that are in a column. We also have data records. Data records are things that are specific to a specific individual person or category, and it runs across different variables. So in healthcare, this could look like a record of a patient. Every patient has a first name, a middle name, a last name, a date of birth, a patient identification number, an address, a street, a city, state, zip code, etc. Now, if we want to look at all the different variables, those are what we call columns or attributes or fields. And basically, they run typically vertically. So instead of looking at my first name, my last name, my medical record number, my address, the column variable, or as sometimes said, field, is everybody's last name, everybody's city, state, and so on. And the tools that we typically use to manage this information is a relational database. And this is electronic database software that manages these different data tables. The table being this collection of rows, being the records, and columns being the different variables or attributes. And to make sense out of this, you can kind of think of it as we need to ask the relational database a question or a query. So with structured query language, or those of you who've heard of SQL, this is basically a programming language that allows us to ask the database questions and get information out. And then finally, we have the entity relationship diagram that shows how the tables in the relational database relate to each other. So again, pretty straightforward stuff, kind of a rehash of what we had. Fields are another way of looking at different attributes. These typically are columns. The table, if you will, is a whole collection of rows and columns. And within the rows, we have the data itself that's spread out amongst these different people that have one common attribute in common, such as a person. A data dictionary is basically the roadmap of the database. And it basically is how we manage our data within the database. And it talks about the type of software, the type of data in each field, the length of the data in the field, any edits, what values are to be placed in there, and a clear definition of each value. For examples, numbers can be strictly numbers, have numerical value, or they can be used as identifiers. So we have to kind of be clear on what these things are. And SQL is a very common programming language that we use with relational database. MySQL, Teradata, all these things are examples of SQL. And basically, it selects data, updates data, inserts rows, deletes rows, runs reports, does all these things that we see in technology today that impacts all of our lives, not just in healthcare, but beyond. Here's an example from a Microsoft Access database. You can see the field name, patient medical record number, followed by the patient last name, patient first name, patient social security number, street, city, zip, phone. These are all field names. The medical record number is the description. It's the patient's unique identifier in the healthcare system, right? So if we're looking at the record of one patient and one patient only, this would run left to right within the database. And the columns, of course, in the table would be running vertically. So with SQL, we have certain commands, and the ones that you see here start in red with select. So in other words, we want select, and then we want the patient's last name and first name from the patient table that you can see right over here. This is the patient table, name of the table right here. And we want to select from that where the patient city equals Milwaukee. So then what we'll do is we'll get everybody who has patient city equals Milwaukee from this table. And we see examples of this in healthcare all the time. R is basically a command line software with a menu driven that does statistical analysis. So we could open an Excel file for analysis and run things in it with R. Statistical analysis software, SAS, is more command line, and R and SAS are both very commonly used in healthcare today. SPSS is more menu driven. And this is common in places like universities, colleges, what have you. And then finally, we have Excel that all of you probably have some exposure to. And this has spreadsheet software, and you can do all different types of statistics, filter data, have different views of data, make graphs out of it. And it does have some sort of database capability. Can add up, summarize, do percents, all very, very quickly, as we've seen. R is basically open source software. It can run on either a Windows or Mac computer. And we'll see some examples of R later on in this course, right? And R is pretty much free. It's open source, kind of like the Mozilla of the Firefox of the statistical software world. SAS, on the other hand, is very expensive. Kaiser Permanente, UC San Francisco, and others are very into SAS. You can think of SAS as a very powerful programming language that does a lot of the same things that SQL does, but it basically also creates data sets and runs on much larger things and across many, many tables all at once without the cumbersome typing out of the commands. And then finally, we have different ways of displaying data. And these are graphs, these could be summaries, these could be charts, tables, and they show relationships between variables. They could show trends, number of COVID cases going up in one thing or another, and so on. And here's an example of some data visualization with this bar chart. We have things categorized, right? And so we have the number of patients age 65 and up, 18 to 64, and 0 to 17. So this is basically a way of categorizing these things and then putting them into a visual display that gives us some numbers with two variables, admissions and age category. Line charts we do to show trend lines. In other words, we're looking at a variable over time. So we have the number of patients discharged, transferred over a certain time period. We don't use these types of charts when we have points that are unconnected. So in other words, line charts are useful when we're looking at the number of COVID cases, say between 2020 to 2024. It's the same connected data, and then we can show the number of it with a trend line. Pie charts are basically comparing parts to a whole. So in this case, we look at the distribution of patients by age group. We're looking at 0 to 17, 19 to 64, and 65. Plus, we're seeing the relative size of it. So in other words, 63 of patients in this group are 63 and up. Scatter diagrams are basically showing the relationship between two variables, right? Two continuous variables, right? So if we have a variable, say like a PSA score, and then another variable, prostate cancer, we can see this kind of a correlation. So if there's a positive linear relationship, this means that the higher the PSA, the higher the incidence or likelihood of prostate cancer is. We don't use these scatter diagrams if either variable is categorical. So if one of the variables, say, is a different type of category of prostate cancer versus a different type of PSA score, it doesn't work so well. So you see these a lot when we have two continuous variables. That's when the scatter diagram works. And then infographics. We see these a lot. CNN loves to do infographics. We saw a lot of them during the COVID pandemic. We'll see a lot more of them with elections and other things. And basically, this is conveying a story. Story could be cause and effect, could be talking about something over time, number of cases, all different types of things we can do with infographics. There's sometimes we want to use tables to display data, and sometimes we want to use graphs. Tables have advantages over graphs. You can present more information than a graph, right? And we can put exact values, right? So you can write a report and say the number of students who have this need or that need at Lane College and categorize it. and a lot easier to do and a lot more readable in a table versus a graph. But graphs also have some advantages. They're visual, so they're very easy to catch the reader's attention. They're very useful for showing trends easily. You can show a chart and show trend over time, and it has a lot more meaning. And then finally, you can look at different points on the graph, and they bring out relationships that get people thinking with trend lines, correlations, and so on. And that's all I have for you. We'll see you online. Bye now.